Welcome to the Aerospace Tech Talks, where we dive into the biggest challenges and most exciting innovations in space and national security. I'm Kevin Bell, Senior Vice President of the Engineering and Technology Group here at the Aerospace Corporation. Today we're talking about a game-changing topic for space mission design and testing, autonomy. From rendezvous and proximity operations to satellite servicing and in-space manufacturing, autonomous systems are becoming essential to these future space missions. To help us explore how aerospace is accelerating this future, I'm joined by Ben Bycroft, Director of our Vehicle Autonomy and System Trust Department. He's here to walk us through one of our most exciting test environments, the CAVE Lab. That's short for Collaborative and Autonomous Vehicle Ecosystem. Ben, welcome to the show. So let's start with the obvious. We appear to be sitting in front of a couple robot arms and some electronics. What is the CAVE Lab and why was it created?
It's a great question. So CAVE is really a systems of systems integration lab. The intent is to bring together software, hardware, and simulation in one hybrid environment so that testing and confidence building in advanced space systems can be done in one place holistically.
So it sounds like the lab's a powerful tool, and what kinds of technologies then are we bringing to bear in the lab, and what does it support?
CAVE's primary focus right now is on autonomous rendezvous proximity operations testing, in-space servicing, refueling, servicing assembly and manufacturing missions, the types of multi-vehicle operations that are starting to become the norm in space concepts.
Okay, so that brings me back to these robot arms. Why do we have robot arms for those missions?
For particularly in-space servicing missions, when you need to approach two vehicles to dock, they need to be able to see each other. They need to be able to estimate their range and their orientation to determine if they are clear to proceed and actually dock, touch each other in space. That's something that doesn't happen very often, and it's something that has to happen with autonomous functions in the loop because it can't have humans making those decisions that require split-second instincts.
Okay, so this lab's able to simulate that on-orbit experience for the hardware, on the benchtop. Great. So how do our customers go about using the CAVE Lab? Is it just an aerospace resource, or do we bring in partners?
That's a great question. So we absolutely use the CAVE Lab for internal development, but it is also available to our customers. The CAVE Lab is built to be a neutral proving ground for technologies so that customers can bring a piece of the puzzle and test in a system context. Now that includes small businesses, startup companies, where the CAVE team is tightly coupled with SpaceWorks and SpaceWorks TRL Bootcamp program, where small businesses that are funded through SBIR contracts are selected to come into labs at aerospace such as CAVE and engage in these testing opportunities they may not have on their own.
Great, so it really gives us a chance to help accelerate industry development, innovation, really not just industry, but industry and our partners in other laboratories. So given that, what are some specific examples that CAVE Lab has been used to either reduce risk or even speed up development time?
Yeah, so the Iron Sight test bed, which is behind us, has been used for in-space servicing missions, looking at fiducial markers in particular. These are small additions that programs can add to their spacecraft that make it easier for computer vision algorithms to identify an object, track its range and location, and go through the docking process more autonomously. Rather than testing those markers on their own, we test them in a system context. So a fiducial marker, a camera sensor looking at it, a computer vision algorithm processing it, flight software, and even representative hardware systems on board a vehicle responding in kind, so that we can see what the impacts of a particular marker, a particular fiducial technology has, not only as a component, but as part of a vehicle system, as part of a mission operation. And we've also used test beds within the CAVE Lab to support some of aerospace's small-sat missions, allowing experimenters testing out first flight items on aboard vehicles such as Slingshot 1, which launched a few years ago, into the ground so they can build confidence in their process, they can make sure that their experiments will go out more smoothly in flight.
So you talked a lot about how we bring the hardware in and are able to demonstrate integration of hardware. How does this tie to digital twins or even simulation in the loop?
Yeah, great question. So the CAVE Lab is really built to be a hybrid of digital twins, of simulation and hardware test. So part of the purpose of CAVE is to allow digital twins to have components of them swapped out with actual pieces of hardware, to let them behave in the loop and test in a way that allows the digital twin to have increasing elements of physical realism injected into it. Find out if those models that a digital twin is based off of are realistic enough to be functional stand-ins for a real system, or if there need to be revisions to models, if we need to update a digital twin once we are in flight, or when we have new hardware coming in as development proceeds.
And so both a chance to actually test the hardware, but then also go back and improve the digital simulation before flight. Fascinating. So what's next? I mean, where do you see this environment going and evolving over the next few years?
So the CAVE Lab and really the entire Vehicle Autonomy and System Trust Department are looking at multi-agent autonomy, integration of AI, artificial intelligence, into autonomous space systems, the importance of trusted AI for space applications, because technology readiness is one axis of the chart. The other side is trust. You can have ready technologies for autonomy in space, but if humans don't trust them, then they're never going to be used in operation. So we are trying to encourage through early and frequent testing the maturation of technology along with trust, so that programs can truly adopt ready capabilities and trust them for use.
So you've got it built in from the front, which I can imagine that kind of watchdog technology is going to be critical for these non-deterministic, sort of AI-driven autonomy systems. Well, before you wrap up, what's the one thing you want the audience to remember about the CAVE Lab?
Really, I would say that integrated testing, and particularly for these emerging technologies in in-space servicing, in AI integration for space systems, testing early, testing often, and testing at the system level is critical to understand both the readiness of a technology and whether you can establish trust in the users of that technology.
Yeah, it's going to be so critical as we build more and more autonomous systems. Ben, I want to thank you. It's been a fascinating conversation. I want to thank thank you for the work you're doing, but also your team here at the CAVE Lab. You're really laying the foundation for the future of autonomous missions across the entire space community. It's enabling our customers, it's enabling our partners, and the nation to stay ahead. So thank you for joining me today. And I want to thank you, to our audience out there, for tuning in to Aerospace Tech Talks. We'll see you next time.